These examples go with Lesson 8.1, Basic Principles of Hypothesis Testing. Example 1. Last year, the mean amount spent by customers at a certain restaurant was $35. The restaurant owner believes that the mean may be higher this year. State the appropriate null and alternate hypothesis. Okay. The null hypothesis, which we are going to call H0, is based on what past evidence has shown. In this case, we knew that the mean amount spent was $35. So our null hypothesis is that the mean is still $35, so the mean is equal to $35, versus the alternate hypothesis. Now we want to say how we think the mean has changed. So the restaurant owner believes that the mean may be higher, and so our alternate hypothesis is going to be that the mean is higher or greater than $35. Example 2. In a recent year, the mean weight of newborn boys in a certain country was 6.6 pounds. A doctor wants to know whether the mean weight of newborn girls differs from this. State the appropriate null hypothesis and alternate hypothesis. Our null hypothesis, again, this is what has happened to the mean in the past, and that is that the mean was 6.6 pounds. Versus our alternate hypothesis, which is going to tell us how we think the mean has changed. Now, the doctor wants to know whether the mean weight, and here's our key word here, differs. Okay? It doesn't say more than, it doesn't say less than, it just says differs, which means not the same. So if our null is that it's equal to 6.6, then our alternate is going to be not equal to 6.6. Because we don't know if it's more or less than 6.6, we just know that we think it's not 6.6. Example 3. A certain model of car can be ordered with either a large or a small engine. The mean number of miles per gallon for cars with a small engine is 25.5. An automotive engineer thinks that the mean for cars with the larger engine will be less than this. State the appropriate null and alternate hypothesis. The null hypothesis will be, in the past, or the only mean that we know here is the 25.5, and so we're comparing the mean for the small engine to the mean with the larger engine, versus our alternate hypothesis, H1. Now, how do we think the mean is changing? Well, we think that the mean for the larger engines will be less. That means that the mean, we think, is less than 25.5. Example 4. A test is made of the null hypothesis mu is equal to 100 versus the alternate hypothesis mu is not equal to 100. The true value of mu is 150, and HO, the null hypothesis, is rejected. Is this a type 1 error, a type 2 error, or a correct decision? Well, let's see. So our null hypothesis was that mu is equal to 100, when in actuality, mu is equal to 150. That means, and those little 3 dots mean therefore, our null hypothesis is false, because we thought it was 100 when it was really 150. All right, in our decision right here, we rejected HO. All right, let's take a look at the chart and see if we made a type 1 error, a type 2 error, or a correct decision. Okay, so our decision right here was to reject the null hypothesis. And we said that the null hypothesis was actually false, which means we made the correct decision. Example 5. A test is made of the null hypothesis, mu is equal to 18, versus the alternate hypothesis, mu is greater than 18. The true value of mu is 20, and the null hypothesis is not rejected. Is this a type 1 error, a type 2 error, or a correct decision? So our null hypothesis was that mu is equal to 18. But we found out that mu is actually equal to 20, which means that our null hypothesis is false. But notice we did not reject the null hypothesis. So let's go back to the chart and find out what kind of error we made, or if we made a correct decision. All right, we decided that we were not going to reject the null hypothesis. Even though we figured out that the null hypothesis was false, it looks like we've made a type 2 error in this case. Type 2 error. Example 6. A test is made of the null hypothesis, mu is equal to 3, versus the alternate hypothesis, mu is less than 3. The true value of mu is 3, and the null hypothesis is rejected. Is this a type 1 error, a type 2 error, or a correct decision? The null hypothesis, we said we thought mu was actually equal to 3, but we found out mu really is equal to 3, which means that our null hypothesis is true. But look what happened. We rejected the null hypothesis. So let's find out if we made a type 1 error, a type 2 error, or a correct decision. The null hypothesis was rejected, even though we found out that the null hypothesis was true. It looks like we made a type 1 error in this case.